So, hello everybody. So this is another bi-weekly call for the TFA Technical Forum. As mentioned previously, we tried to do a presentation about an interesting subject and then have some Q&A at the end on more general matters from the mailing list. I have asked previously, and I'll mention it again, if there's anybody in the project community wants to present anything in future, please drop me a line, Joanna Farley at arm.com, and or on the mailing list, and I will endeavour to try and schedule some time for you. So as you can see from the agenda today, we've got Lauren with us, who's going to give us an overview of the unit test testing approach that we're looking to adopt. Anyway, without further ado, I'll stop screen and hand over to you, Lauren.
Okay, cool. Share my screen. Can you see my screen?
Yeah.
Yes.
Okay. So I'm going to give a introduction into the unit testing framework we have for TFA. First go through a concept of unit testing briefly, and then go through the framework and its components, and then discuss some future work we have planned. So start with concept. So there are 4 levels of software testing. We have unit testing, the testing of each unit separately, integration testing, which is checking multiple interacting units together, system testing, testing the whole system against the specification, and then finally acceptance testing, checking the business requirements for delivery. So a little more on unit testing. So it's the testing of small isolated software units and object-oriented units, class, and a C unit would be a set of functions around a feature. So C, C++ unit tests and the code under test are compiled into an executable. And some of the advantages of unit testing are there's less errors caused by the lower abstraction level. And then it validates the existing behavior in every run, which helps with refactoring. It makes the programmer able to test more rare events since it's a more directed approach. It encourages modular software structure. It helps documenting as it works as an example code. And another advantage in an embedded environment is that it helps development without hardware. So there are a couple of disadvantages. It definitely requires more work from the software developer, but it helps to pay off later. And it doesn't test all the interactions, so higher level testing is still required. So it's just one part of the testing strategy. So to get into our current framework, it's currently internal because we have a new C picker tool that's part of the framework that's not available outside of ARM yet. But at its current stage, we're able to define and build unit tests. It's able to run with LCOV-based code coverage. This is good because it's the same as what we use for FEP TFA code coverage. There's documentation for getting started, building, running, and debugging tests, and we already have some mocks that have been implemented for TFA. And then also we have the new C-Picker tool, which can split code fragments from original code, map coverage back to the original code location. So to break it down in the different components of the framework, we have CMake as the build environment, CPPU test as the unit test framework. This includes the mocking framework, CPPU mock. There's the C-Picker tool, it's the Python-based code cut tool for isolating functions. The code under test is TFA. And then the unit test repository is TFA unit tests. So this has the unit tests, the mocks, and the build system and utilities. So we get further into each of these components. So CMake is the tool that to describe and generate build systems. We've chosen it also as the build system for TFA. So if you want to learn more about that in detail, Javier had done a presentation in May, so that you can find on the Tech Forum site. And motivation for why we chose it for an additional one for why we chose it for unit test framework is because it includes C-test. So that's an executable. And CMake generated build trees created for projects that use the enable testing and the add test commands have testing support through C-test, which will run the tests and report the results. So a little more about CPU test. It's based on it's based on a XUnit test framework. So we've chosen it because it has C support. It has a small framework. It's easily portable for embedded systems. It has the built-in mocking system, which I'll go into a little more. It implements the XUnit 4-phase testing approach. You can select the run of tests, and it has the standard output format. So some of the functionality of CPU test is this little framework. So you have the test group, which is the test suite. It's a C++ class, and it can contain additional variables and functions. You can see like examples of this on the right side of the screen. There's the test setup and test teardown, which are called before and after each test run. And then the tests themselves, which are the test cases, and they're the function of class inherited from the test group. The test group members are accessible to the test and places global object, its constructor registers, the test case. There are also the built-in assertions in the framework. So it has assertions like check true and long equals, which you can see in the example here. So on the left is an example of memcopy test, and on the right is an example of how it would be in a test suite, and then some different test cases for it, and then it uses the long equals assertion on the right. And then all of the test cases can be run through the main with run all tests. It's all built in the CPU test. So for the CPU mock framework, it allows you to replace objects by mocks to simulate the behavior of real objects. So mock returns the global mock support. You have the callbacks expect one call or expect n calls. That enables you to record the expectation from the test case, and then the call to actual call records the actual call from the replace function. So that then you're able to, on the right, you can see them. First, the expect one call is called, then the actual test case is run, and then the check expectations make sure that those are in alignment, and will flag if those don't match. So some additional functionality for CPU mock is the expected actual calls can be seen by specifying an object, which allows you to check whether the call was done to the right object. With parameter allows specifying and checking of the call parameters, and return value allows specifying the return value from the function. Some additional functions too that are built in are the enable disable, which allows you to enable disable the mocking framework. Tracing, which allows you to get the trace output, and the check expectation, which was in the previous example. So allows you to check for non-fulfilled function calls, and then also clear for clearing expectations. So the cpicker tool, so it's a Python tool internal to ARM. It allows unit test flexibility and breaking dependency between C items defined in the same file. So these aren't separated otherwise, which would limit the mock options. Why we needed that. Yeah, the code under test, TFA. The unit test system expects a local copy of it, and you can specify it by setting the TFA path variable. And the new build system of TFA will fetch the unit test repository and build itself, and test itself. So, and then the actual framework itself, the TFA unit tests, it has the CMake modules, fetch content, unit test, which is a function for defining unit test suites, the unit test source files, and the CPP UMOC-based mocks for common parts of the TFA code. So the platform, log, and panic is what we have so far. Root CMake list.txt, it allows you to define the workflow of the system. And then there's also documentation included so far. So to get into a little bit of the future work we have planned for this. So we need to determine how unit testing will fit into the test strategy. We're trying to decide if it's going to be optional or mandatory and potentially be used to fill coverage holes. We need to determine if and how unit testing should be publicly released. We need to do this for the unit test framework itself and also the CPicker tool. We need to split CMake files to the framework and build definition. We'll merge the framework part to the CMake framework, but this obviously depends on the CMake framework being released. And then also we need to add automation in platform CI. We need to find a way to document the test cases themselves, find an optimal way to do that, and then also just add unit tests for existing and new features. So that was my little intro into unit tests. Does anyone have any questions?
Hi, Lauren, it's Alexei here.
Hey.
So my question is, this is the test suite that is supposed to run for C files from TFA, is it correct?
Yes.
And what TFA modules can be actually tested with this framework?
So any of them, well, there's not many tests so far. We have about, I think 3 or 4 so far, so it just needs to be built up. But any of the modules can be tested down the road. We just need to build the framework more.
So my question actually is that most of the C code in TFA is a platform dependent or architecture, ARM architecture dependent. So, and as I understood, this test actually runs on PC, is it correct?
Yes.
So it's not run on the ARM architecture. So the compiler which is used is different to the compiler which we are using. Compiler options are different. And the architecture which is used to test this framework is different to what we are using. So what is the benefit of running this unit test? Because you can't test most of the code which we have in TFA. For example, the first example which comes to my mind is a libc library. But even in libc library, in your example, there was a memcopy function. And because the architecture, ARM architecture is different to x86, for example, we are compiling with a not aligned access being disabled. You can't actually test exactly the same examples and the test cases as you test for ARM architecture. So what's the benefit of this unit test? Because you can't test a lot of stuff.
Well, I believe we can. So I have yet to create a test myself, but I've been looking through, I mean, I think we're able to. I just need to look more into it. I can get back to you on that.
Can I jump in?
I'm okay.
Sorry, can I jump in?
Yes, yes, sure.
So this on this specific topic, I believe that part of it is solved by the mocking functionality, because mocking is about providing an alternative implementation for functions that have a dependency on hardware or the architecture. You provide an alternate implementation that works on the on your host machine. So that means that we can test, I think, a lot more than maybe you originally thought. And the second point is that I believe unit testing would be mostly used, you know, at it's about testing at the function level, or at least a small granularity. And I think we would be using that to really test the functional behavior. Like to take the example again of the mem_compare function, you don't really care about whether you have aligned or unaligned accesses authorized. It would be mainly to check that the contract, you know, is not violated. Like you've got, you know, yeah, that your mem_compare function has a defined contract where you must not you provide two buffers and it compares them. They must not overlap, and you just feed inputs into them and check that the output is correct.
Yeah, you're checking the expected value.
Sorry, Lauren?
So yeah, you're just checking against what's expected. So you input the expected value and check that.
Yeah.
Well, what's important here is it's another way of testing the code base. I mean, traditionally we've used a lot of the TFA tests, which has its own limitations. So that this is another way, or broadening the spectrum of types of testing that we can do in our code base. I don't think any one is a perfect mechanism to test everything. So it's just broadening the, with different types of testing, we're hoping to find different types of bugs.
Yeah, this isn't a one size fits all. We have lots of different testing methodologies to make up the bigger testing strategy for TFA.
I mean, like last week, or was it last week? Recently, Mark has presented the SMC fuzzing, to provide a fuzzing type of test capability on top of the TFA tests, and that this is adding another variation. I mean, you mentioned at the beginning, which I'm sure a lot of people outside of ARM are probably not aware of, that we've been working on a code coverage type solution for the TFA project, and that's in the process of being open sourced and should be available upstreamed at some point in the future. And that allows us to measure the type of testing that we do, and have we got the coverage on the line coverage, function coverage, and branch coverage, I think is covered. And of course, having these different types of testing, and there are others that we could think of, just gives us more tools to try to target different areas to make sure we've got a higher level of test coverage.
Yeah, but my question would be, if we know what we need to test and how we need to test, why not to include this test in TFTF and link to the libraries which actually come from TFA? So we are not creating our own libc for TFTF. We are just using the source tree from TFA to test it.
So this just gives more control. So you're able to have more directed approach and actually just isolate the actual function you want to test. It's definitely breaking it down in a further way.
Yeah, but you can break all the functions and use this broken test suite for TFTF. Just another test suite.
The thing is that TFTF, it's running at EL2, so it exercises the trusted firmware mostly, if not only, through the SMC interface. So you can really only test what's exposed as an SMC. So if you want to test a specific function that is deep down into the call stack in TFA, that's rather complicated without getting a whole lot of side effects from the calling functions. Or you have to introduce some kind of SMC, specific SMC to invoke this specific TFA function directly in some test mode specifically. So it's just a lot easier to use the unit test route whenever you want to test a specific function. And also, I think it's just another argument is that it's just easier to run these tests on your host machine rather than having to run that through a software model or directly on hardware, because if you do that, you have more things, more infrastructure and tools to deploy, basically.
Yeah, you typically write a function with a contract, right? I mean, so there's one of the things we were talking about on a code review, right? You're expecting that a pointer is not null, and that is the contract you're exposing. So you write a test that says, okay, if it's null, it should blow up. And if that contract changes, your unit test is going to fail. And then, you have to,
yeah, but you can't test if your pointer aligned or not aligned, because it will run on x86, but it will cause an exception on the ARM architecture platform.
Oh yeah, so you need to have asserts in code, right? Or fail if it's not aligned. And that's the point, right? So you need to express those conditions in code or in terms of asserts or in terms of unit tests, right? So yeah, usually these things just are assumptions that we write into code that never gets tested, right? So this is where something like that would be extremely useful to document the functions contract. Yeah, I expect aligned pointers. I don't expect nulls. And if that ever changes when somebody changes the function, yeah, it's going to get caught.
I think the key idea here was the initial statement in one of the previous slides where it said that you want to test the unit in isolation. So, I mean, maybe instead of looking at libc, if we look at, let's say, the GIC driver as a unit and, its interaction with the hardware. So there are a lot of registers that it reads and writes and expects certain bits. So if we test that entire unit in isolation and mock all the hardware interactions, then we can test each and every bit instead of having to run it on actual hardware and try to simulate situations so that each and every registers can be.
But I think it's not possible to mock the geek. It will be just like a software model for the geek, so you can't do it actually. So I think any device driver can't be checked and tested with this unit test framework.
No, I mean, when I say mock, so any accesses there, you can, return whatever faulty values, you can return the actual values, and you can see how the unit is going to use those value. Is it going to assert properly? Whatever asserts there are, can you hit them? And all those kinds of scenarios can be tested with unit testing. I mean, just positive testing is fine, but I think it helps mostly with the negative testing part, and something that you cannot reach with with the integration testing. So, I mean, the approach that you're talking about is mostly integration testing. So if you see that, let's say take all the units and run them together, and then that is one level of integration. And another level of integration would be entire TFA along with the actual hardware, like the actual ARM CPU. That would be another level of integration. So, I mean, before even your unit touches the hardware, this kind of unit testing can help you, catch a lot of other scenarios without having to run it on the actual hardware. I mean, that's how I see it, and that's how internally also we've been running the entire TFA, and we've taken a similar approach. Maybe we don't use the same tool, but yeah, we've taken the same approach, and definitely it has helped reach crevices of code which you normally cannot reach with just by issuing an SMC.
Okay. Any further questions?
Yeah, hi. So actually I wanted to understand, is this, so firstly, how do you define a unit internally? Do you treat each function as a unit, or do you treat, let's say, a driver as a unit? How do you define the scope when you say, when you call a unit a unit?
I think we're using a function level currently.
Oh, okay. Okay. And so how much of this is manual effort versus automated when you start testing the unit? I mean, for example, if you have to mock everything outside of the unit, then is this something that a developer has to do, or are there tools which can, you know, automatically try to do this for you, like give you some sample mocks?
Currently, the developer has to do this. We have some sample test cases, but yeah, they have to build out that themselves when they're developing a specific.
Okay, okay. And is it also possible in the framework to test out assembly code and mock assembly code?
Not currently, no.
Okay. So is this a limitation of the framework, or it's just they'll say framework supports it, but
yeah, that's the limitation of the CPPU test framework.
Oh, okay. And you also talked about the coverage numbers using LCOV, I think. So I guess this all of the, I mean, when you treat a unit, you build it with LCOV and then you get the coverage numbers directly on the host. So, I mean, is that like straightforward, or do you have to extract them from somewhere after the test has run?
No, we get it directly on the host. And yeah, I think we plan to go through more of our coverage in an upcoming forum.
Okay, okay. Right. I mean, I talked about how we do it internally. So instead of looking at each function, what we have done is look at a bigger component as a unit. So for example, a driver, as I said, I mean, that can be a unit. You know, each library, so let's say the PSCI library can be a unit. And so that's what we treat as a unit. And that helps. I mean, we did it for different purposes, mostly for the safety work that we've been doing.
Okay.
Yeah, but I think yeah, we did not look at each function as a unit. So do you have any, you know, you said it's manual efforts of for, you know, testing and mocking and getting all the results. So I don't know if you have any, you know, general numbers as to how much time effort it is to mock. Let's say, I mean, taking the memcompare example. So we can build up on top of it. Let's say, I mean, if you have to test out 2,000 lines of code, so using that as the base, then we can figure out, you know, how much time it's going to take to test out the entire TFA.
Yeah, I don't have those numbers right now. I think so. We only have a handful of test cases at this point. So yeah, I think that'd be a future thing to figure out how. But yeah.
Right. No. Okay. Yeah, I just wanted to understand. I mean, even the manual effort and time eventually might, you know, discourage some people. So I just wanted to understand that part.
Yeah.
Thanks.
I think it all depends on how dependent on the hardware the functionality you want to test is. The more it accesses devices, registers, stuff that are you know, specific to your platform, the more mocking you will have to do. But I would expect that for the memcompare function, typically, there would be no mocking to do at all, because it's really just an algorithm. I mean, a very simple one, but I mean, it's really just functional behavior. There's no dependency on the hardware, except maybe as we were talking about aligned accesses or not, but I'm not sure exactly how we would express that in a unit test.
Hi, can I jump in?
Yes.
Yeah, hi. I think one of the modules that the unit testing will be really helpful is the PSCI. The PSCI involves a lot of hardware specific actions such as turning on MMU or or enabling coherency or caches. There's still a lot of algorithmic code, especially which does the coordination, where you actually do things like tree traversal. And these trees are basically representing the power domain hierarchy. And there are a lot of depth first search or breadth first search kind of mechanisms here. And it's very easy to get into a mistake, like to perform a mistake of accessing over the bounds. And so I'm guessing unit testing might be helpful in such scenarios.
Yeah, I think it's interesting you brought the libpsci unit. So I just wanted to understand, Lauren, does the framework also support passing large data structures? Let's say libpsci expects some structures from the platform. So is that supported?
I'm actually not sure about that, but I can get back to you on that.
Okay.
Hello, this is Vijay from Steam. So I have two questions. So like when a platform driver or code is getting introduced in the DFA depot, right? Um, um, so what kind of tests do you expect from the platform side? And the second question is like, is there a plan to adopt TDD? Meaning that, is it expected to write test case before writing the function?
So sorry, are you kind of couldn't fully hear that question? A little broken up, but so you're wondering what the expectation for writing unit testing would be?
Yeah, in terms of the platform code, right? Let's say I am writing a driver for SCMI, SCMI called to SCP, right? So this is the interaction between the AP core and the SCP code, right? So what kind of unit test should be right? And then since the test will be running on the host PC instead of FEP, right? So how it is going to get handled? So that's the first question, and then the second question is like. Is there expectation like the test case should be written at first before writing the function?
So yeah, I think those things still need to just be determined. We need to figure out how this like fits into the whole testing strategy, where it's going to be present, and yeah, the usage of it.
Okay.
Yeah, to support Lauren there, I think what we've been trying to do is investigate different types of testing and what tools were available to us for the work that we're doing on this project. And this was something that part of the team put together, and we can see the benefits of unit testing as such. And of course, now we need to apply it. Now we can see how the framework could be used within the TFA project, and so hence we're coming to the tech forum, sharing what we have here. There isn't so much expectation as you need to write this type of unit test for this component and this type of unit testing for that. I think there are things that will come out as we try to use this, and people as I said, can look at the spectrum of types of tools that we're trying to develop or try to have available to us, and choose the best one for the type of testing that you want to do.
Okay, thanks.
Hey, Lauren, initially you also said that you compared it with some Google tests. So which test is that specifically? Do you know the name or, So
Actually not. I can ask, it was actually someone else who had done that. I can ask them which ones they had looked at.
Okay. And this test, I think you said it's going to be available to the community. So it's not, none of it is proprietary, right?
So we have the new tool developed, the seed pickers. So we just need to get some license for that. But yeah, that's the only proprietary.
So the plan is to make this available for for other developers, not just the folks within ARM to make use of if they wish, for either their platform testing or for any core code work that they may be involved with. Yeah, so even though I saw that it talked about internal repositories and things, the plan is to make them external once things have matured a little bit.
Okay, so I guess I'll stop sharing my screen. And back to you, Joanna. Joanna, are you muted?
It would help, wouldn't it, if I unmuted myself? So as I was saying, can you hear me now, folks?
Yeah, we can hear you.
Yes.
Good. Sorry. Yeah. So as I said, we're at the point now where we're, if there's no more questions about the unit test framework, we can start talking about anything that has been brought up on the mailing list generally over the last couple of weeks, or any other urgent subjects that people would like to talk about. But before I do that, I just want to put out the request again. If there's anybody wants to share anything, have any presentations, anything they want to share in the tech forum, please reach out to me or on the mailing list, and we can look to schedule some time to do that. I'm thinking of creating a wiki page or something to keep a list of ideas of things that might be upcoming. We often don't decide until a few days before the next tech forum what we're actually going to talk about. But if I can put up a wiki page with the details of ideas and things, people can at least have a look at that, or even suggest new ones that they would like to contribute. So this is the digest of the various discussions that we've had. Is there anything here anybody wants to follow up on? I'm not hearing anything that anybody feels the need to talk in the tech forum about these. Hopefully these discussions can continue as necessary in the mailing list. Is there anything else anybody wants to talk about? Otherwise we might be finishing a little bit earlier today.
I have one question from the mailing list. I see Jan on the call. It's regarding the libftt upgrade, and in the patch he mentioned that we should also add the fdt_check.c file. Should I continue the discussion on the patch itself?
Who's that a question for? Sorry.
Sorry, it was a question for Jan. Sorry if I'm not pronouncing it right.
Maybe it's better to include the file.
Jan, you are very quiet, at least for me. Cannot hear you very well.
Yeah.
Okay, sorry.
I can't hear you.
Maybe like this, better?
A little bit better, Pra.
Okay. So I was saying that I have no strong idea.
Sorry, we can't hear you.
It's probably my mic, I think.
think we can hear what you say, but the volume is very low, so it's quite tough to make out.
Understand. Yeah.
Like this is better.
I'll probably continue the discussion on the Gerrit patch itself.
Okay.
Sorry about that.
Is there anything else anybody wants to talk about? All right, so looks like you got a quarter of an hour back of your life. Thank you for joining. I appreciate this is a little bit earlier now than it was previously. Hopefully that's not too much of an issue for folks. Unfortunately, we were clashing with some other trustedfirma.org meetings, and we were asked to sort of move around so that other people could attend multiple meetings. I will be taking the recording of this and uploading it, hopefully in the next day or so. And you'll be able to review this and the material at the trustedfirma.org TFA Tech Forum meetings page. Okay, so thank you everybody, and speak to you all again in a couple of weeks, or next time we engage on the mailing list.
All right, thanks. Bye.
Thank you. Bye-bye.
Thank you.
Thank you. Bye.
Bye.